Welcome to the workshop. My name is Jingjing Wu, and I'm the web librarian. And my colleague Cynthia Henry and I will run the workshop together. So our workshop serial has 4 sessions. We will focus on using R to process data, especially the research data. It is not for the general R programming. When I say the R programming, I mean developing applications or writing functions. So here on this slide, could you see the slide or? Okay. Okay, so this slide briefs what we are going to cover. So session 1, this is for today, and we are going to give an introduction to R and RStudio. We will also talk about vectors or the atomic vectors, which is the basic data structure for R. Next week, we will talk about another data structure, that's data frame. That's a data structure R uses to process tabular data like CSV files or Excel spreadsheet. On February the 3rd, that's session 3, we will use dplyr and tidyr to process the data. Let's say add new columns or fields, apply summary statistics, or reshape data between its long and wide formats. On February the 10th, session 4, that's the last session, we will use ggplot2 to visualize the data. ggplot2, dplyr, and tidyr, all those are R libraries or packages. We will install them together later today. If you are interested in other sessions, you may have to register for them one by one. We don't have an option to register for the entire serial. You should have already received my email yesterday. It includes links to download R and RStudio, as well as the installation instructions. So you can find all the links on the workshop guide. I think I can put the workshop guide here.
Got it, Jingjing. I already did it.
Okay, thank you, Cynthia. Okay, and also the email also includes a link to the pre-survey, which help us understand your expectations better. If you haven't filled up the survey, and please do, and we appreciate your support. Today's workshop is 2 hours, and we will take kind of 5-minute break at around 3 o'clock. This curriculum we are using is based on a carpentry course, a data carpentry course. It's called R for Social Scientists. So you can find the link in our guide. We understand learning online is not easy, especially for hands-on workshop. And when you need to code along. And we also borrow workshop setup suggestions from carpentries. And so you can see the preparation tab here. So kind of you can set up your workspace based on your settings, how many screens or how many devices you are using. If you have any questions, please use the chat box or unmute yourself to speak up. So today we are going to cover the basics of R, RStudio, R package installation, objects in R, R functions, vectors, and missing data. If you could not finish missing data, we will talk about that next session. Before we dive into R, I would like to know what software or tool you use to process, analyze, or visualize your research data. I think I set up a poll here. Could you see the poll? Okay. That's a multiple selection, multiple choice question. Then we see the results here. Yeah, we see a lot Excel spreadsheet. And also we see some OR and RStudio. Okay, cool.
And a bit of SAS and SPSS down at the bottom. That's the next one left. Yeah.
That's the kind of statistics software. No one is using OpenRefine, and so R is an open source free data analysis program. It interprets a programming language, which is also called R. So R refers to both programming language and the software interprets the scripts written using it. RStudio is an integrated development environment for R, and it's called IDE. An IDE is a piece of software that provides tools to make programming easier. Okay. To use R, RStudio is not required, but it makes your experience with R more productive and more enjoyable. The RStudio is currently the most popular IDE for R. To function correctly, RStudio needs R. So you need to install both on your computer. If you haven't installed them, you can go to the guide page. Depending on your operating system, download and install R first and then RStudio. The installation process is very intuitive, basically following the step-by-step instruction. If you use Mac, check the Mac version first. Make sure you download the correct version of R and RStudio. And also you can find the instruction in the guide. Why do we want to use R and RStudio? R is free, we just mentioned. It's not only free, but open source. So anyone can inspect the source code to see how R works. Because of its transparency, there is less chance to make mistakes. Anyone find a mistake, they can report and fix the bug. And it's cross-platforms. And we can install R onto Windows, Mac, Linux. It's very convenient for people using different systems. R has been broadly used in many research areas. For example, biomedical or social sciences. From the registration, we can see that you came from very different backgrounds. And I saw people from media and communication and plant and soil science. Actually, several years ago, I attended a course. It's by the Plant and Soil Science Department. I don't know if you still have the course. I think the course name is R for Data Science. And the textbook we use is also R for Data Science. And the book is still very helpful. And yeah, I think we have that link. We have the book in the library. And also I already put the link to the book in the guide. So the R has over 10,000 packages to extend its capabilities. Later, we're going to install a package. It's called Tidyverse, which is a kind of a collection of packages. It includes dplyr, tidyr, ggplot2, and more. R also has packages for specific areas, let's say GIS or bioinformatics. Talking about research data or research, we know that reproducibility is important to research and to sciences in general. We see journals retract papers because of the reproducibility. When we pick a tool for our research, we wanted to improve the reproducibility of our analysis, allowing us to automate and document the analysis process. So R is such a language. R is a scripting language, and the analysis process is written into scripts. So we can run the scripts to redo the data cleansing, analysis, or visualization. Or when we collect more data, we can rerun the scripts. And RStudio integrates with version control tools like Git or Subversion. So we can keep track of changes we made to our code. We can also revert to previous versions of a file. RStudio provides a way to keep all the components of a data analysis project organized into one folder. It is RStudio project. I will walk you through the process to create an RStudio project later. And also our Markdown document is written in Markdown, which is a plain text file format. It combines the documentation and analysis all the code into a single file, which is best for human understanding. It's a good practice for research reproducibility. We won't go deep into this part, but we will take a quick look at an example. So here on the left, you see this is kind of the coursework. That's the chapter, the first chapter before we start. And at the back end, it is our Markdown file, look like this. So this file is kind of on my GitHub. Have you already get R and RStudio installed? If yes, please let me know using the green check mark under reactions. If you need any help in installation, Cynthia can help you in the break room. Okay. Okay. So do you want me to give you more time to finish the installation, or we can just go ahead and move forward?
It looks like we're about half with our check marks of green. And some people have said yes in the chat. So yeah, it looks like people are asking to please continue. We have one person that's waiting on IT for authorization, but that's it.
Okay. Okay, so as most people are ready for the next step, we will kind of move forward now. So first, I'm going to show you where R is and how our interface look like. So here, I'm using Windows, and then under Windows, and you can see, you can scroll down to R. And then here you can see my version is 4.1.1. And I think the newest version will be 0.2, I mean 4.1.2. Okay, when I click, I open the R console. Okay, so first you see this prompt, this kind of greater than prompt, which means our console is ready to accept a command. We can run commands from here. Let's say we do a very simple calculation, and then we get the results. And also we can run some commands, say get working directory, and then you can see this is my current working directory. And also we can print out the famous hello. When we put some kind of commands, it's incomplete. Let's say +2 minus, oh, sorry. And we hit enter. We will see a plus sign here. We can either finish it, let's say we -2, and then we hit enter, we got the results. Or let's say, and then when we hit enter, but we don't want to finish it, we can just use escape to jump out. And now we see a new prompt here. So R is ready for new commands now. So we can put our R commands, R code here, but it's much less user-friendly than IDE. So this is kind of why we want to install RStudio. So next, we are going to talk about RStudio. We can use RStudio to write code, navigate files on our computer, and inspect variables we created and view the plots we generated. First, I'm going to close this file, and we don't want to save anything. So as we know, RStudio is an integrated development environment. It offers all the information we need to write code in a single window. So it also has many shortcuts and auto-completion, which makes the typing easier and less error-prone. Okay, now we open an RStudio. So we will kind of talk about, this is kind of my, RStudio is opened, and we will first see the interface. And we will start with the interface. So on the left side, you see this is the R console. That's the same our console as we just saw, where you can type in commands and see results right away, and but your code won't be saved. So this is kind of the space for quick tests. Here you see the prompt, the same kind of prompt. When we create a new R script file, so we can do from here, R new file, R script, or we can just use this file icon with a plus sign and then R script. Then it's kind of create a new file. And so this area, we just call that code editor or script editor, where we can put our codes here. And also we can save the file. We will save the file later. So on the right side, the upper pane, we can see the environment history here. And the lower pane, we see files, plots, and help packages. Let's say when we create a new object, let's say A, and equal 3, and then we can see it shows up here in the environment, which means A is currently in the memory. And also we see this is the command we just run. So we can see that in the history. We already kind of talk about RStudio features which can improve the research reproducibility. Now I'm going to walk you through some good practices. We know that we want to automate and document our analysis into scripts rather than the environment. How to avoid hidden dependencies on our R environment. We will talk about two concepts. The first concept is workspace. In RStudio, the workspace is the current R working environment. It includes any user-defined objects. Let's say currently we have A defined in the environment. At the end of an R session, we can save an image of the current R space as an R data file that will be automatically reload the next time R is started. This automatic reload is a default behavior. It sounds amazing, but not recommended, because if R automatically saves and loads our environment, when you manage multiple projects, R may save or load the environment of project A to or from project B. Or when you share your code, data, or results with your co-workers, they do not have the same environment as you do on their computers, and they could not run your scripts successfully. The same, if we migrate those files to another computer or to another folder to continue our work, the new location may not have the environment. So we don't want to save the workspace to a file, and we don't want the workspace file to be automatically reloaded the next time we start RStudio. Now, it comes the first good practice, the workspace setup. So first, under tools, and you can see at the bottom, global options. So the first tab is general, and we see workspace here. So restore our data into workspace at startup. That's something we don't want. So make sure this is unchecked. And save workspace to our data on exit. There are 3 options. Make sure we select never. And you can click OK or apply to confirm this setting. Another concept is working directory. The working directory is a place where R will look for and save files by default. The current working directory you can see here is on the top of this console. It's kind of the title area. So this is my current working directory. And also you can use the get working directory command to check. So they are the same. When we code in R, we use relative file references or the relative paths to the working directory. When we change the working directory, relative paths in our code will become invalid. So we don't recommend changing the working directory within an R session. Instead, we recommend create an RStudio project. So here is kind of our good practice too. Create an RStudio project. So we still under file and create project. It takes a while. Okay, yeah. And you see the first option, new directory and new project. And here it allows us to kind of pick the directory. And I want to use the desktop. So I just select desktop and click OK. And here the directory name, let's say this is on R workshop. So I just use R workshop and bring and click create project. Okay, so now you see the working directory is changed to this new folder I just created. And also you can use here. This is the kind of the create a project icon. So that will bring the same interface. And also here, you can create a file, just like here. Create a script. Now it's back kind of 4 panes. We just created an RStudio project and an R script. And I will quickly show you where you can connect to a version control tool or where you can create an R Markdown file. So first, about the version control tool, you can connect to a version control tool under File, and then still New Project. And here, version control. And you can see Git or Subversion. You can pick any of those. Okay. We're not going to connect to. And another place you can do is under Tools. I think there is a version control and project setup. And here you can pick the Git or Subversion, and then we can pick Git. It will ask me if I want to initialize a new Git repository for this project. We're not going to do that. But in the real world, it's very good. It's a good practice to use the version control software. So next we're going to talk about the R Markdown. So you can create a R Markdown file. It's here and R Markdown. Okay. So these two parts are also important kind of RStudio features support the reproducibility. I mean the research reproducibility. One of the main advantages of using projects is that after closing RStudio, if we wish to continue where we left off on the project, we can simply double-click or open the file saved here. This is the file, I mean the RStudio project file. Then it will open this file and RStudio start up and open the scripts we were editing. Another advantage is that if you click on 2 or more different R projects and you start new RStudio and R sessions for each, so you will see the working directory change right away. Just like when we create this one, we see the working directory change. Now we're going to talk another good practice using a consistent folder structure across your project to organize your working directory. This consistency will help keep things organized and make it easy to find and file things in the future. This can be especially helpful when you have multiple projects. In general, we may want to create kind of directories or folders for scripts, for data, and for documents kind of separately. Here I can show you example of suggested structure. So this is your working directory, and you can create those folders to organize your project. So data, we generally use this folder to for your raw data or intermediate data sets. For the sake of transparency or provenance, you should always keep a copy of your raw data and do as much as possible to clean up or pre-process your data with scripts rather than manually. So data output, let's say when you need to modify your raw data, and it will be useful to save the modified version in a separate folder. And documents, that will be kind of the documents help people understand or help yourself understand the project. Fig output, this folder, you can use that to for your graphics or for the visualizations you created. And scripts, that's a place to keep your R scripts for different analysis or plotting. You may also want to create additional directories or subdirectories depending on the project needs. But this kind of the basic one, the backbone of your working directory. So to create these folders, there are different ways. You can also create from the, let's say, where is the folder? Our workshop. Oh, this is the folder. So I can always create the subfolders or directories here, just as you usually do on your computer. But we will use RStudio to do that. So you can use our commands. Let's say you can use the command dir create, and then you put the folder name here. Let's say we want a data folder, and then we hit enter. Then we see under the working directory, we see a new folder, data is created. And also we can create here using this kind of icon, new folder. We want to create one script. Now we can save our empty script into this scripts folder. So we click save, and then it will ask us where to save. And for this one, we can name it as introduction to, and then we save it. When we click this folder, we see this file here. The file size is 0. We don't have anything. As the workshop serial is based on the data carpentry course R for social scientists. So we know that survey is a common research method in social sciences. So the data sets we are going to use through the 4 sessions is the survey data from the website Figshare. So we will see the details of the data next time, but I will put the URL in the chat. So this is the URL we are going to download our data set. So to download a data set, we can use the command download file. And then we will put the URL here. So next, we are going to specify where we want to put the file and what's the name of this file. We want to put it under data. That's the raw data. And then this project is called SARFI. That's the study on African farmer-led irrigation. So SARFI, and then this is already the clean data. So it's a CSV file. And then we will add mode. That's the WB, which means writing in binary mode. When we hit enter, this file will be downloaded and we see the file size. And also we see this message in red. This kind of RStudio kind of give us message, whatever, if it's an error message or whatever message, it will display in red. So don't panic if you see the message in red. It doesn't mean you do anything wrong. So here we can check the data. It's under the folder data, and this is a file name. Okay. So next, we're going to install an R package. So to install an R package, we're going to use the command install.packages. The package we're going to install today is Tidyverse. I already have the package installed, so I'm not going to install it, but you can hit enter and see the installation. You will see a result like this. Still the red message, the message in red, and then it tells you this package is successfully installed. It may take a couple of minutes. Let me try. Let's say if I put my command here, could you run it?
While we let somebody try to run that download again, we have a question. What does the mode equal WB mean?
Okay, WB means writing in the binary mode. So basically we have two modes. That's kind of my understanding, the binary modes and the text modes. And this time we use the binary modes.
And how is everybody else doing? I think we just have one person kind of trying to get that download, but maybe everybody else is doing good. Okay, I see some green thumbs ups.
Okay,
yeah.
Cool. So everybody get the package installed?
Did you say, I'm sorry, I missed, did you say, I got a question, do you want to install from sources the package which needs compilation? And I'm supposed to say yes, no, or cancel? When I ran the package install, it asked me that at the end. Do you want to install from sources the package which needs compilation? It says there are binary versions available, but the source versions are later.
You can install the binary version.
And so I say yes. Sorry.
I think yes means source, but you can try yes.
Okay.
And we have somebody else that had the same question as well. So
Ah,
they got that message and
okay.
so Kristen, you try and say yes as well.
And also another way to install, and here you can use the package tab and then click install and then put the tidyverse here and make sure you check the install dependencies and then click here, then it will the same. It will run the same command.
So Brad dropped some more information in the chat. Jean, did you see that?
Okay. Yeah, I saw that. Okay, I think you can use no. I think you can use no, but if yes doesn't work, we can try no anyway. I don't know if compilation here needs a C environment or not.
Okay, thank you. It did the compilate. I didn't realize I needed to type. I couldn't find the cursor to type, so I hit enter. And so I think that assumed I was saying yes. So that completed and I've gotten the download. So I should be caught up with everybody. Sorry for the delay.
Oh no.
Yeah, and Jean, will you just type out the install line again? So we got the download, but let's type out the install line for
Okay.
yeah. And then I think we'll all be together again.
Okay, install packages, and we just put tidyverse here. And also you can use the package to install. Just put tidyverse here. And then make sure you check the install dependencies and click install. If you already got the package installed, please use the check mark to let us know. So
Could we look again at the PowerPoint so we can see the line for the tidyverse install? Yes, so this will be what you'll see on your screen. And so even though there's a lot of red there, don't panic. It will be okay.
this is kind of what we have for the first hour. And well, some of you are still installing or downloading the package. I can quickly wrap up what we just talked about. So this is the takeaways for the first hour. So we kind of talk about the RStudio interface. We have 4 panes and script editor and console, that's the left side. And we see the environment history on the upper right corner, upper right. And then the files, plots, and help at the lower right corner. And also we talk about reproducibility process. And we mentioned RStudio integrates version control tools. And also we see the our markdown file. We can use that to combine both code and documentation into one file. And we check the global settings for our data. And we don't want to save the workspace to an image file, and we don't want to reload it next time we start RStudio. We created an RStudio project together, created subfolders, and we saw the folder structure example, and we suggested using consistent folder structure for all your research or analysis projects. We are installing the R package tidyverse. We see 2 different ways, and we can use the command or we can use the packages tab. If you have any problems installing the package, please let us know. And otherwise, we can take a 5-minute break. We will come back. Okay, I can set up a timer. Let's see.
Okay, let's talk about some of that. It looks like Kristen and Katie are having some error messages. And maybe even Brad.
Okay. Okay. I don't think that's a error message. It says already downloaded 411 kilobytes.
Yeah, I think Brad is good. I think that Katie right above that, and then
yes, our tools. Okay. Oh, actually, it is recommended everybody install our tools. That will kind of prevent some errors happening. And yes, you can install our tools. But I have never seen any error message. That's why. So anyway, you can download our tools from here and install that. Yes, it depends on the Windows version. I mean, yeah.
Sure. You want to drop that link in the chat for Katie?
Yes.
Thanks. Okay. And then I think we still have one more question that was just sent to me, Jing. So we have somebody that we're not sure if it's working. She keeps getting an error message saying, warning, install packages, installation of packages, CLI had non-zero exit status. Let me retype that
One.
and so you can read it. Here it is in the chat now. And that's Kristen. So Kristen, if you need to come off of mute and have a conversation, feel free to do so.
Okay, if you get a error message and you don't know what's going on, that's kind of the debug part. And you can just put the message in the Google and no non-zero exit. So CLI is your directory path. Is that true?
Mm.
Zero exit status.
Okay, so Kristen dropped some more information in the chat. Package.
So could, oh no, I. Framework. Let me see my. No. This is just my guess. I think maybe you can try a different path. You can install to a different place. Is the folder or is the directory r.framework? Is this the one you create yourself? I don't know if it supports the dot. Oh no, yes, it has 4.1. Yes, it won't. Do this again.
Maybe, Gigi, maybe Kristen and I'll go in a breakout room and see if I can help her solve that issue. And then we'll be back after that.
Okay.
And y'all can move on. I'll be right back. What do you think about that?
Oh, okay. I just refer you to this kind of this page, and then you can see if they offer solutions here.
Okay. Thanks.
This is the page, kind of the people got the same error message or similar error message.
Okay.
So Christine, are you using Linux or Windows?
No, I'm on a Mac.
On Mac.
It might have worked now. So I removed the package and tried again and said no when I got the do you want to install from sources the package needs. And I got something else this time. So maybe it worked this time. I'm not sure.
Okay. Well, we can always try to go forward and see if you get an error again.
Okay, maybe you can just try Mac first and then see. Okay, another way, Christine, could you check if you already have it installed under the package? Did you see tidyverse installed on the list?
Well, it's there. Yes, it's there now. Yes, I can't. I've gone through removing it and trying to reinstall it several times now, and maybe it's working now. I can't tell. I don't know.
Oh. Okay, if you run another command, it's called library. Oh, sorry, this is not what I did. You can run library and then tidyverse. Did you see kind of the similar message as what I see here?
Yes, and then I seem to have a few extra warnings afterwards.
Okay, I think you already installed that. So,
Oh, yes. Yeah, she dropped it in the chat as well, and it looks very much similar as separate. It does have a few more warnings there.
Interesting. I've never seen those before, but anyway, I will look into that. I think for now you are good to go. And there are two things we can look into. One is the page the URL I just put into the chat box, and another thing is we can read carefully this. What does that mean? But usually a warning message, it means you may have some minor issues, but it won't really impact your environment or impact what you still can use it. Okay, so it's a little bit past 3 and we can start we will move forward. Before the break, we saw some simple calculation in the console and assigned a value to an object A. I think after we create the new file or create a new project, the object we created A disappears. And now we're going to talk about the object. What is an object? Objects in R are known as variables in many other programming languages. And in this workshop, we are going to use objects and variables interchangeable. We are going to see more object examples, but this time we were going to use script editor instead of the console. So first, we're going to see an example converting kilogram to pounds. We know that a value in kilogram times 2, kind of inaccurate. Let's say equals to the value in pounds. So we can create a variable or an object. We call that kilogram to pounds. And we know it's kind of approximately to 2. So we will use this sign, less than and minus, or less than dash. And then we assign the value 2. And when we had a command in the script editor, we want to run it, we use Control Enter instead of Enter. Now in the console, we see this command is run, and also in the environment, we see a new object is created. So the object name is kilogram to pounds, and the assignment operator, we can use equals, but this one is kind of the R tradition. R is an old language that kind of came from those old tradition, and it shows the direction. So we assign the value 2 to this object. And for this assignment operator, we can use a shortcut. That's the Alt minus. We just assign the value to the object, but it doesn't print out anything. So if we want to check the value, we can just put the name here. So when I type the first 3 characters of this object name, you can see it pops up, and I can use tab to auto complete this object name. And then when I hit Control Enter, you will see the results display in the console. So next, we're going to try some conversion. So say we have something, it weighs 4 kilograms. How many pounds does it weigh? And so we can create another object that's weight in pounds and equals to we have something weighs 4. Okay. And then we can Control Enter. Now we have another object created here. And we see the value is 8. And also we can check that from here. We know that 2 is not accurate. We want to be a little bit more accurate. Let's say we assign another value, 2.2. It's better. And then we Control Enter to run this command. Now the kilogram to pounds, this object, the value is 2.2. So what's the value of the weight in pounds? Is the value still 8 or it's 8.8? Okay, we see, thank you, it's 8. Because we haven't change this value, we can run this command again. Control Enter. Now it changed the value. So we just named two objects, weight in pounds and kilo to pounds. When we name an object, we need to follow some rules. So first, we cannot start object name with a number. An object name is case sensitive. So the suggestion is we use lower cases. And also we cannot use reserved words. And R has some reserved words. And I will post a link. That's kind of the complete list of all the reserved words in R. Okay, so we can see here, if, else, repeat, they are all reserved words. We don't want to use them. And also, when you put a reserved words here, you can see it changed the color. Another suggestion or another rules we want to follow is avoid dots. Yes, you can use dots. I mean, when I say dots, it means this period character or this symbol. It has special meanings in R, so you can, but we recommend you don't use that. And usually we use nouns for variable names and we use verbs for function names. And also we should avoid existing functions or variables. Otherwise, it will override existing value. Just as we saw, we assign a new value 2.2 to kilogram to pounds, and then it changes the value. It updates the value without any notification. Another rules we want to follow is make your object name meaningful. That will be helpful for your coworkers and your future self understand what you are doing. And we can use, sometimes we could not use only one word to kind of express the meaning of this object. We can use underscore as separators. We can put several words together. We just kind of talk about the rules for the object naming. It's important to keep the naming consistent. Also, when we code, it's important to be consistent in styling, especially for those who just started coding. It's good to develop good habits from the very beginning. Code is not only read by machines, but by human beings. Consistent styling makes them easy to read by yourself and by your coworkers. So in R, there are 3 popular style guides, or 3 popular styles. And I think I already put the links to those guides in our guide here at the bottom. So next we're going to talk about comments. All programming languages allow the programmers to include comments in their code. The comments help us or help our coworkers understand the code easier. So in R, we use hashtag. That's kind of the shift 3. So anything right to the hashtag will be commented out and ignored by R. So we can add comments kind of in the same line with the code. Let's say, we can say convert kilogram to pounds. And usually we can also start at the very beginning. When we create a new file, we want to add some information about this file. Let's say we want to add a title here, introduction to R. And also we can add the author, and we can put date here. When we want to comment out multiple lines, we can use, we can highlight those lines and use Control-Shift-C. This is a kind of the shortcut when you want to comment out multiple lines. Control-Shift-C. And if you want to check all the shortcuts, and you can use Alt-Shift-K. So that will open the keyboard shortcuts. We can also add kind of the session title. We can put the session title like objects, and add at least 4 dashes or 4 minus. That will make this part a section title, and then you can fold it. Next section, we are going to talk about functions and their arguments. So we can use, we can create another section. We can also use shortcut Control-Shift-R, and we can add functions and arguments. Let's kind of help you organize your code better. So we're going to talk about functions. Functions are candidate scripts. So basically, we use functions to fulfill certain tasks. Many of them are predefined in base R. For example, it's a very kind of simplest one. That's the square root, SQRT, square root. That's the function for square root. A function usually gets one or more inputs. So we call that, we call those arguments. So let's say we want to see the square root of 9, and then we run it, Control Enter. So we got the results. Functions often, but not always, return a value. Let's say for this square root function, we have one argument, and then it returns a value. when we execute a function, we always say we run a function, or we say we call a function. Arguments can be almost anything. It's not only not necessary to be a number. It also can be a file name. And it can be the directory name. We already see that when we run the, when we create the directory. Some functions have more than one argument. Let's say round. The first argument will be the number we want to round up. Let's see. That's the first argument, x. And the next one is how many digits. And we want to keep 2 digits. And we can run, and we got 3.14. Also, if we don't put digits there, and when we run that, we got 3. Why? Because the digits has a default value, which is 0. So it will round this number up to 0 digits. So there are many functions. We could not remember all of them, and we could not remember all the arguments. So, but we can check the help document. We can use the function help to check the help document. So it will open the help tab, and we can see round here. So round has 2 arguments, x and digits. And digits by default is 0. And also, when we have more than one arguments, the arguments came in different orders. Let's say as defined, x comes first, and then digits. This order also matters. Let's say if we want to, if we kind of follow the order of the arguments, and then we don't have to specify which is which. It will round the first number up to 2 digits. If we don't follow this order, we have to specify. Change this number to 3. So a good practice for this is to put the kind of follow the order the arguments are defined, and we usually put the one without any default value first, and then if we want to kind of use a different value than the default, we just specify the argument. That will make it easier for people to read, especially those who are not familiar with this function. Also, we can nest functions. We can put round and this is kind of the very basics of function. If you are still with me, yeah, could you click the green check mark? Okay, so we will move on to next part. Next section, we're going to talk about vectors. We create a new section called vectors. Okay. So in R, a vector is a data structure. It is composed of a series of values, which can be numbers or characters. If all the elements of a vector are of the same type, when I say the type, which I mean if all of the vectors, all the elements are numbers, or if all the elements are characters, they are kind of the same type. We call those kind of vectors atomic vector. If a vector contains elements of different types, we call those list. All the vectors we're going to use today are atomic vectors. So we use vector refers to atomic vector to make easier. And also in some books or documents, vectors refers to atomic vector. So first we talk about how to create an atomic vector. The function we're going to use is C. So we name our first vector household members. And then we have different numbers. Control Enter. We will see this new object created. A vector can also contain characters. Let's say we want to create a vector of the building materials. We call that respondent wall type. We use C and Markdown and front brakes and some brakes. So this time when we create all the elements are characters, we need to put them into quotes. Otherwise, R will treat them as objects, but those objects have not defined. So we will get an error message. So when we check the respondent word type, we can see the results here in the console. R offers several functions to inspect the content or the attributes of vectors. So we can, first we can see one like length, and we can check members. It will check how many elements. So we have 4 elements, so we get the length 4. The same if we check the word type, respondent word type, we got 3. Another function is type of. We use that to check the data type of a vector. We know the vectors, all the elements are of the same data type. Yes, and so we can use type of to check it. So when we check household members, it's double. In R, we use double or numeric to mean the floating point. So they basically have the same meaning as these are the number. This is a number, so this says double. And also we can check the word type is character. And another function we're going to talk is str. It will give you a brief summary. So you can see it is number numeric vector, and it has 4 elements, and they will list all the 4 elements. The same here, we can check the respondent word type. Character, 3 elements, and if they have more elements, and it will cut. I could not remember where they will cut, how many elements they will keep. But anyway, we will see maybe later. So some people say str, this function is kind of your best choice. It depends on what you want to, what elements or what attributes you want to look into. So we just saw use C to create vectors. And also we can use C, this function, to add elements to an existing vector. So this time we create a new vector called possessions. And we use the function C. We have bicycle, we have radio, and we have television. And we can add elements using the same function C. But the first thing we put here is possessions, and then we add mobile phone. The same, we use C, and this time we put a new element in front. Let's say we have car, and then we have possessions. Now we can take a look what possession is now. So now we have 5 elements. First, we append a new element to the end, and then we add a new element to the front at the very beginning.
Jing, we do have a question in the chat.
Mhm.
When we have the bracket with a first number and colon and a second number, can you tell us what the first number is? So like right after we ran the string for respondent wall, we had character 1, colon 3 in our results.
Up.
No,
No.
sorry, on line 44, and then your results are right below, but yeah.
Oh, the brackets. Okay, we're going to talk about the brackets right away. Actually, this is the index of the vector. So it shows the first through the. This is the first, the index 1, and then this is the index 4. How can I explain that? This is kind of shows the range. Column number, as this is a vector, we don't have the concept column now, but this is kind of, we just have 4 elements. This is the element 1, element 2, 3, and 4.
So it kind of gives you the total range, as she was saying.
Yes.
Like we cannot get to a 5 in this string.
No.
Yeah.
Okay. So there are basically 6 main atomic vector types. We just saw 2, character and double. That's the numeric. And so they're kind of the basic building blocks for all the R objects. And the other the other 4 atomic vector types are logical. Logical is kind of true or false. And integer, they are just integers. And complex. Complex, it represents a complex number with a real and imaginary parts. So it's kind of look like something 3 plus 4i. So that's the 3 is the real part, and the 4 is the imaginary part. So that's it can be used in very special situations. And the last one is raw. We are not going to talk about that. So yeah, that's kind of the 6 vector types. And mainly we will use the numeric or double and character, logical, integer, and sometimes maybe complex. Oh, for integer, let's say when we assign this household numbers, we assign some integer numbers, but still it shows numeric or shows double as the type. If we want to specify one vector is integer, we need to add something, let's say integer, and we can assign with C, and then when we check the type, we will see integer. We need to add an L at the end.
And help me remember, Jing, stubble is S-T-U-B-B-L-E, is that right? How do you spell stubble?
Double, it's just the double.
Oh, D-O-U-B-L.
Yeah.
Sorry, that was my bad.
No. So you can run this and see this is double.
Yes, I'm sorry.
No. So we know that all the elements of an atomic vector must be of the same type. So when we attempt to combine different types, they will be coerced to the most flexible type. We can see an example. Let's say we can create a new vector. We assign it, let's say we have a number, we have a character, and we have a logical, and we have an integer. That's kind of the most used 4 types. And when we assign it, oh, okay. And then we try to take a look. Okay, I just put it below this. That will be okay. Then we can see those 4 elements, but differently. All the elements are put into quotes, which means they are now character vector. So these coercions happen according to a hierarchy. So where some types get preferably coerced into other types. If you want to, you can play around yourself. Let's say we know when we have an character element and it will be coerced into characters. When we remove this, remove the character type, and then we can check it again. So it's double now. It's a kind of coercion.
Is double kind of the same as ratio?
Ratio, we don't have ratio in R. I mean, as a data type. R basically use double and numeric.
Okay.
And then we have another question. How can we remove an element from a vector?
Okay, we will do that later. I think ratio, we just don't use the language. Yes, it is ratio. I can say, yeah, you can say that, but that's just not the language R uses.
Okay. Well, you said there's double and numeric though. So what's the difference between double and numeric, especially if you know, we had integer on here already? So
I can just say they use that for those kind of the floatings. I don't know other vocabularies for those kind of the floating points. I mean.
okay, that's fine. I might just be thinking too much in terms of SPSS anyways.
Okay, so next we're going to talk about subsetting of the vector. Subsetting. When we say subsetting, we mean we kind of get some elements from a vector. So in R, we use square brackets to subset a vector. So there are 2 ways to subset a vector. We can use index, just like we saw this. It's the whole set. We have 4 elements, and this kind of means we use the, how do you call that, colon, is that colon? We use colon, and then that's the index 1 through 4. So that's kind of the whole set. Okay, so to make it easier, we can see an example first. For the respondent word type, and if we want to see the second element, we can just put 2, and then we got burnt bricks. And also we can put more than 1 element in the square brackets. So this is a vector. There's 2 elements, 3 and 2, and we put them in the square brackets, which means we're going to get the third and the second element of this vector respondent word type. When we run it, we see we got some bricks and we got burn bricks. If you still remember how this vector looks like, we have 3 elements, matdao, burn bricks, that's the second one, some bricks is the third one. So this time we got only the number 3 and the number 2. Subset doesn't mean we got a smaller set of data or smaller, we got kind of less elements. It can be more elements than the original one. So we can put, let's say, 2, oh no. Run it. We got 5 elements in the new vector, but we didn't really rename, we didn't name this vector, but that's the results. We have only 3 elements. Now we use only 1, 2, 3 as the index. Could we use kind of something different? Let's say, could we use negative index? Let's say -2. When we run it, we got 2 elements. The first one, matdao, and the third one, some breaks. This way, we can remove the second element. We can also, let's say, use a larger number than 3. We know we have only 3 elements. If we use 5, we got NA. In R, NA means missing data. So which tells us we don't have the 5th element in this vector. And also one thing to mention is about index. In R, the index starts from 1. If you have some programming experience with other languages, let's say Python or C, the index of those languages starts from 0. We just mentioned this is kind of one way to subset use index. And another way to subset is we can use conditional subsetting. Let's say we use conditional subsetting means we use a logical vector. So true, which means we'll select the element with the same index, while false will not. So we can see an example. Let's say still, this time we want to use the household members. And first we can take a look how it looks like. It has 4 elements. And now we want to subset using a condition. So we already know we have 4 elements. So we put true, we put another 4 element vector. That's a logical vector here. And then when we run it, we see only 2 elements left. So the second one and the third one are removed because they are false. But typically, these logical vectors are not typed by hand. They can be output of another function or some logical tests. For example, we want to keep the values above 5. So we say greater than 5. When we run that, we got logical vector. So we know the first one is smaller and all the other 3 are larger. So when we put this logical test in the bracket, greater than 5, and then we got the 3 elements. All of those are greater than 5. We can also combine multiple tests, multiple logical tests. We can use and or logicals. So we use the pipe for all. Pipe, which is kind of right under the backspace using shift. Use and. Oh, this one. We want to combine when combining multiple tests. So let's say we want the household members, which is smaller than 4 or larger or greater than 7. Okay. So first we use the bracket, square bracket, and then we members smaller or less than, and then we use the pipe for all. only these two elements left.
And Jing Jing, we're 5 minutes out.
Okay. Okay, so thank you for reminding me. And we can see an example, but we can use the right. Yes, I think so. We have only 1, 6. We can also use the equals to kind of search the specific elements in an vector. Let's say we already see the possessions, and it has 6 elements or 5 elements here. And then we want to see equals to. When we do the kind of comparison, we use double equal sign. We want to see if it's car or possessions equals to bicycle. So we have only these 2 elements left. So this is kind of what we're going to cover. We didn't have time to cover the missing data. We will talk about missing data next time. And I think I still have another slide. That's kind of the takeaway for the second hour. We talked about the object. Everything in R is an object, and the variables, we assign a value to a variable, and using the assign operator, and we can use alt minus or alt dash. This is a shortcut. And also we talk about vectors. We focus on atomic vectors. That's the basic data type or data structure in R. And it has 6 types, but we only cover 4. It's kind of double, character, integer, and logical. And we inspect the content and attributes using length, str, and type of. We use length to check how many elements, and we use type of to check the type of the elements. And str gives us a summary of this vector. We also talk about subset. We use the square bracket to subset. There are 2 different ways. We can use index, and also we can use logical vectors.
And then I've dropped the evaluation form in the chat if you have to run off. We know we're right at the time.
Oh, okay, yeah. Thank you. If you have any suggestions, please put in the evaluation form. Thank you for coming.